Let's take a look at linear approximation when you aren't given an a value. In this case, you need to choose a number that is close to whatever x value you're trying to evaluate and easy to evaluate for the given function. For example, if you have the square root of 80, you want to approximate this using an a value that is close to 80 and easy to take the square root of. So we would use a is equal to 81. If we need to find the tangent of 29 pi over 180, we need to use an a value that is close to 29 pi over 180, but easy to take the tangent of. So we would use a is equal to 30 pi over 180, which is close to 29 pi over 180, and simplifies to pi over 6, which is easy to take the tangent of. If we are trying to approximate the cosine of 61 pi over 180, we would use a is equal to 60 pi over 180, which is close to 61 pi over 180, and equivalent to pi over 3, which is easy to take the cosine of. Let's see how to use these in order to find linear approximations. If we're trying to approximate the square root of 64.5, that means that we're looking at x is equal to 64.5. So if we need to identify the function, we have f of x is equal to the square root of x, and we're going to approximate this linearly at a is equal to something close to 64 and 5/10, but easy to take the square root of, which would be 64. So now we can find f of 64, which is equal to the square root of 64, which is 8. So we have a and we have f of a. In order to find f prime of a, we have to first take the derivative of f of x. The derivative of the square root of x is 1 over 2 root x. We can then use this to find f prime of 64, which is equal to 1 over 2 times the square root of 64, which is 1 over 2 times 8, which is 1/16. We now have a, f of a, and f prime of a, so we can find our linear approximation. L of x is equal to f of a, which in this case is equal to 8 plus f prime of a, which for us is 1/16 times x minus a, so times the quantity x minus 64. We can then use this to approximate the square root of 64.5. That means that we need to find L of 64 and 5/10. This is equal to 8 plus 1/16 times x, which is 64.5. I'm going to move this. So 8 plus 1/16 times 64.5 minus 64. So this is 8 plus 1/16 times 64.5 minus 64, which leaves us with 5/10. So this is equal to 8 plus 1/16 times 1/2, which is equivalent to 8 plus 1 over 32. This is simplified enough without a calculator. So we have that the square root of 64 and 5/10 is about, or approximately, 8 plus 1 over 32. Now let's take a look at approximating the tangent of 61 pi over 180. Here, x is equal to 61 pi over 180. So that means that the function that we will use to approximate this value is f of x is equal to tangent x. When we will find the linear approximation at a is equal to something that is close to 61 pi over 180, but easier to evaluate. So that will be 60 pi over 180, which is equal to pi over 3. So we can find f of a, so that's f of pi over 3, which is equal to the tangent of pi over 3. If this doesn't jump out at you, you might remember that tangent is equal to sine over cosine. So we have sine of pi over 3, which is root 3 over 2, divided by, which means we can find the reciprocal of cosine of pi over 3. So that's the reciprocal of 1/2, which is 2 over 1. So tangent of pi over 3 is equal to root 3. Then we need to find f prime of a, so we'll start by finding f prime of x. The derivative of tangent x is secant squared x. For the purposes of evaluating, we can rewrite this as the quantity of secant x squared. So f prime of a, which is f prime of pi over 3, is equal to the quantity of secant of pi over 3 squared. The secant is the reciprocal of the cosine. The cosine of pi over 3, as we found earlier, is 1/2, and the reciprocal of that is 2 over 1. 2 over 1 squared gives us 4. We now have everything we need to find the linearization. So L of x is equal to the square root of 3 plus 4 times x minus pi over 3, where we have f of a plus f prime of a times x minus a. We're trying to approximate tangent of 61 pi over 180, so we need to find L of 61 pi over 180, which is equal to the square root of 3 plus 4 times 61 pi over 180 minus pi over 3, which we will rewrite as the equivalent fraction, 60 pi over 180. You could also find a common denominator the old-fashioned way. Simplifying, this is equal to the square root of 3 plus 4 times 61 pi minus 60 pi gives us pi over 180. So, the tangent of 61 pi over 180 is approximately the square root of 3 plus 4 times pi over 180 simplifies to pi over 45. Now we will approximate 1.003 to the 7th power. Here x is equal to 1 3/1000. So f of x is equal to x to the 7th power. And we'll find the linear approximation about a is equal to something close to 1.003, but easier to raise to the 7th power, which would be 1. F of 1 is equal to 1 to the 7th power, which is equal to 1. Now we need to find f prime of a, so we'll start by finding f prime of x. The derivative of x to the 7th power is 7 times x to the 6th power. Now we can find f prime of a, so f prime of 1 is equal to 7 times 1 to the 6th power, which is 7. We have all the pieces we need to find the linear approximation. So L of x is equal to 1 plus 7, so that's f of a plus f prime of a, times x minus a, so x minus 1. Now we can use this to approximate 1.003 to the 7th power. So we need to find L of 1.003, which is equal to 1 plus 7 times 1.003 minus 1, which is equal to 1 plus 7 times 1.003 minus 1, which leaves us with 3,000. That's equal to 1 plus 7 times 3 gives us 21. So 7 times 3,000 gives us 0.021, which leaves us with 1.021. So 1.003 raised to the 7th power is approximately 1.021. Finally, we want to approximate 1 divided by 1 and 200. So here x is equal to 1.02. So f of x is equal to 1 over x, which you can write as x to the negative 1 power if it helps you. And we'll find the approximation at a is equal to something close to 1.02, but easier to divide 1 by, so we'll use, once again, a is equal to 1. F of 1 is equal to 1 over 1, which is 1. Then we need to take the derivative of f of x. The derivative of 1 over x is equal to negative 1 over x squared. So f prime of a, or f prime of 1 in this case, is equal to negative 1 over 1 squared, which is equal to negative 1. Now we have everything we need to find L of x, our linear approximation. This will be equal to f of a, which is 1, plus f prime of a, which is negative 1, times the quantity of x minus a, which is x minus 1. We can then use this in order to approximate 1 over 1.02. So we need to find L of 1.02. This will be equal to 1 minus x, which is 1.02, minus 1. So 1 minus 1.02 minus 1 gives us 0.02. 1 minus 0.02 gives us 0.98. So we have that 1 divided by 1.02 is approximately 98 hundredths.